Hello, you guys. Welcome to another dosage calculations lecture. Today, we're going to be talking about dimensional analysis. If you've been going with this lecture with us through this lecture, you know last time we introduced dimensional analysis. Now, today, we are going to do several problems using dimensional analysis. I think we'll do maybe one problem with D over H times Q, and then we'll go right into our dimensional analysis. So grab your pencil, grab your paper so that you can follow along with us, so that you can get your practice in, learn about dimensional analysis, and be able to work these problems. So this is presented by Apex Nursing Academy. Let's get started. All right, you guys, we are going to practice dosage calculation problems. These problems we're going to work out using dimensional analysis. I think we'll do this first one just to do a quick review on D over H times Q. We'll work the first problem with D over H times Q, and then the rest we'll do dimensional analysis. Now remember, if you do not know how to do D over H times Q, or you need a better review, go back to our first lesson of the series of dosage calculations. I'll provide the link here, and you can review what D over H times Q means and really how to work those problems. Then we advance on to dimensional analysis. So there's plenty of lessons before this one with D over H times Q practice. So go ahead and practice those. If you still want to review and practice doing problems by D over H times Q. But for a quick review, we'll do this first one. And it says a healthcare provider has ordered Lanoxin 0.125 milligram PO daily. You have available Lanoxin 0.25 milligram. How many tablets will you give? So let's just pull out our values for our D over H times Q. D. Remember, D is just our desired order. It's just the physician's order, the healthcare provider's order. So D is going to be 0.125 milligram. What do we have on hand? We have available Lanoxin 0.25 milligram. And that is going to be per tablet, right? Each tablet that we have, the available tablets, each tablet is 0.25 milligram. Let's check our units of measurements here to see if they are in fact the same unit of measurement, which they are, milligram to milligram, so we do not have to convert anything. Remember, if you don't have the same unit of measurement, say you have gram and milligram, you need to convert, right? But in this case, we do not have to convert, so we can plug in our values and calculate. So our D is 0.125 milligram over H. What do we have? 0.25 milligram times 1 tab. If we divide 0.125 divided by 0.25, we get 0.5. Milligrams cancel out, times 1 tab. And 0.5 times 1 is 0.5. So we are going to give 0.5 tablet, right? So that's our D over H times Q. Did y'all get that problem? I scrolled up way a little bit too much. Scroll down a little too much. All right. Get that out of your way. there. There we go. All right. So I think I set up for these problems. I really didn't make it in a paragraph form with long sentences. So you'll just see the order, what we have, and the question. So here we have this order for atoxamoxetine 200 milligrams. What we have is an 80 milligram tab. It wants to know how many tab or tablets will we give. Now remember, we're going to use dimensional analysis. And with dimensional analysis, you are setting up an equation to work out your problem. You want to end with what you desire in the equation, but you have to introduce the other units of measurements and then get those other units to cancel out so that you only end up with the unit of the measurement that you're looking for. So how do you know what you're looking for? Is you go by the question, and it's asking you how many tablets will you give. So you always start with what you're looking for. So we're looking for tablets, right? So tablets equal. And then you want to start with, when you're building your equation, that's the dimensional analysis, is building an equation. So you're going to start with what you're looking for is the tablet in this case. So that's what you're going to put in your first set of your equation. One tablet is 80 milligram. Now we got that information from the problem. What we have here, 80 milligram. So one tablet is 80 milligram. Now in all your setups in your dimensional analysis is going to be multiplication. So we're going to multiply and we're going to build our next setup. And remember, when you're building your next set, you let the denominator, the unit of measure in the denominator, guide you to the unit of measurement for the numerator. So we have milligram in the denominator here. So for our next set, we're going to have milligram in the numerator. So how do we find what we need in the numerator? Well, we look at our order, and our order has 200 milligram, right? Now let's see our setup here. I'm going to use a different color. We have introduced into our equation tablets and milligrams, right? So tablets and milligram is in our equation. We're looking for tablets, and we're trying to get tablet be the only thing in our equation. We want everything else to cancel out. So at this point, we have milligrams on top and milligrams on bottom. So that cancels milligrams out. All we are left with is tabs in our equation here. Milligrams have canceled out, and we have tablets left. So we know we don't have to go any further with building other sets over here. We don't need to do that because we've canceled out milligrams and we only have tab. So now we can just calculate. We can multiply. We can solve our equation. So if we do 200 times 1, that's 200. And remember, if you need to see a 1 here, put a 1. This is a whole number, 200. So remember that when you have a whole number as a fraction, you put the whole number over 1. So you don't have to put 1 there, but if you need to see a number, go ahead and put 1 there. So 80 times 1 is 80. Now we just divide that out. 200 divided by 80 is 2.5. And this is going to be tabs. Okay? because this is what we have left, our unit of measurement in our equation. Milligrams cancel out and we have tabs, which is what we were looking for. Okay? If you have any questions, if you have any concerns, put that in the comment so that I can see it and I will respond. I want you all, I'm going slowly and I'm really breaking things down so that you all can see the parts of dimensional analysis, okay? Let's try another one. All right. We have Ritalin. The order is Ritalin 10 milligram. What we have available is Ritalin 5 milligram tab. How many tab or tablets will you give? Dimensional analysis setup. Start with what you need. What are you looking for? You're looking for how many tablets. So we're going to write tab equal. And we're going to start with tablet when we set up our equation. So to look at our first setup, we're going to look at what we have. We have 1 tab equals 5 milligram. That's our first setup. We know we're going to multiply and we're going to look to the denominator to guide us to what we put in the numerator. We're putting milligrams in the numerator because we have milligrams in the denominator. And remember, we want to cancel out milligrams because we're looking for tabs and we only want tabs in our equation. But we have to get to a point to cancel out this other unit of measure, which in this case is the milligram. So we're going to put our 10 milligram in the numerator and we're going to put it over 1. Okay? Now we have enough setup here to cancel out milligrams and we just have tab left. So we don't need to set up another part of the equation. We can solve the equation now. So 1 times 10, and you just multiply straight across on the top and the bottom. 1 times 10 is 10, and 5 times 1 is 5. And when you divide that out, 10 divided by 5, you get 2. And 2 what? 2 tabs. All right? 2 tabs. So I'm writing a little big and I'm really trying to make some marks here. It looks a little messy if you're not following me, but I really want to explain the components of setting up your dimensional analysis equation, okay? So bear with me. It may not be pretty, but I'm explaining here, so I want you all to understand this and be able to work out problems. So let's look at our next one. Our order has nitroglycerin 13.5 milligrams, PO Q12 hours. What we have available is nitroglycerin 9 milligram tab. How many tab or tablets will you give? Again, we're looking for tablets. So yes, you got it. We are going to put tablets here. And we're going to start with our first setup in our equation as tablet. 1 tablet is how much? You are right if you said 9 milligram. We get that from what we have available. Milligram is going in the denominator is going to lead us to numerator, and we're going to get that from the problem, from our order, which is 13.5 milligram. All right, 13.5 milligram over 1. We don't need to go any further because we have milligram canceled out, leaves us with tab. We can multiply, solve by multiplying, and get our answer. So 1 times 13.5 is 13.5. And 9 times 1 is 9. So 13.5 divided by 9 is 1.5 tab. And that's your answer. That's how many tabs you give. 1.5. Alright. Y'all get that? Let me know if you don't understand, or if you're missing any part of this. Let me know. Otherwise, I'll keep going through. We'll go to the next one. We have albuterol sulfate syrup, 8 milligrams PO daily. What we have available is albuterol sulfate syrup, 2 milligrams per 5 milliliter. How many milliliters will you give? So this time it's asking for milliliter. Well, we're going to do the same setup. We're going to use what we're looking for first, which we're looking for milliliter, equals. Let's put our milliliter in. What does our problem tell us? From what we have to look at what we have. That's where we're getting this information. So it may not always be 1 tab or 1 milliliter. You have to look and see what your problem actually says, and that's what you put in to your equation. So this is 5 milliliters. 5 milliliters, 2 milligram. Okay, 5 milliliters, 2 milligram. Same concept. We need milligram in our numerator. We're going to look to our order, right? So 8 milligram. We can put a 1. Our milligrams cancel out. All we have is milliliter left, so we're okay to solve. 8 times 5 is 40. 2 times 1 is 2. 40 divided by 2 is 20 milliliters. Okay, 20 milliliters. That's how many milliliters we're going to give. Once you work these out, you really get going. It just takes practice. It just takes practice. You get used to doing it and you'll get more comfortable doing it, and the more you practice, the better you'll get. And it's good to practice so that you can see different values in different problems, so that you don't get stuck if you see, hey, I have 5 milliliter like that. Well, this one is like that. What we have on hand, well, our order is furosemide 25 milligrams PLQ 4 hours, and what we have on hand is furosemide 20 milligrams per 2 milliliters. So you may not always have 1 tab or per 1 milliliter or per milliliter. It may not say that, so you can't just always think you're going to put 1 tab or 1 milliliter into your equation. You have to just put what is given to you in your problem. So this one is asking us how many milliliters again. So we are going to start with milliliters here. We're going to put our 2 milliliters because that's what we have on hand, and it's 20 milligrams. We know we're going to cancel out milligrams, so we're going to put our 25 milligrams in the numerator. We are good to go to solve because we are able to cancel out milligrams and leave milliliters. So 2 times 25 is 50. 20 times 1 is 20. 50 divided by 20 is 2.5 milliliters. That's how many milliliters we are going to give. You guys are doing great. All right, let's keep going. Again, though, for any reason, if you have any question, let me know. If I'm going too fast, stop the video, pause it, work out your problem, and come back to it. Okay, because go at your pace so that you can mentally work through this problem, get the practice in, and make sure that you are getting every step and that you're understanding every step. Okay, so we have acetaminophen 750 milligrams PO Q6 hours. What we have available is acetaminophen 0.5 gram per tab. How many tabs will you give? Well, let's find out. We are going to set up our problem. We have one tab is 0.5 gram. All right. One tab is 0.5 gram. We have introduced tab. We have introduced gram. We're going to use our numerator to go to our denominator to go to our numerator. So we have gram. So we have to put gram in the top, right? But when we look at our order, we have 750 milligrams. So what do we do? Are we stuck? Do we just throw everything out of the window? No. Like I mentioned before, dimensional analysis, you don't have to remember formulas, but you do need to remember conversions, because you need to use the conversions into your equations when you have to convert. Okay? So if you remember your conversions, 1 gram is equal to 1,000 milligram, right? 1 milligram is equal to 1,000 mics. All right. So those are ones that you just have to commit to memory, your conversions. That's a common one. Those two are common conversions used all the time. So it's not going to hurt you. It's going to only help you if you commit those two to your memory. Another one is the milliliters to teaspoons. Remember, I was telling y'all about that. Commit to memory. So we have to have grams in our numerator. So we need to get to milligrams. So if we get to milligrams, we have to set it up as such. We have to say 1 gram is equal to 1,000 milligram. That's how we introduce milligram into our equation, but we have to do it the proper way, and that's the way that we have to do it. Okay, we have to keep order, and we have to keep everybody in their place. So let's look at what units we have in our equation. We have tablets, we have grams, and we have milligrams. Now we're looking for tablets, so we want to keep tablets in. We have enough to cancel out grams, but we still have milligram in here. So what do we need to do to get rid of milligram? Yes, we need to make another setup. Now we can use our order from our problem, which is the 750 milligram. That's where that comes into play. Now we are able to cancel out milligram. We don't need to go any further to set up our equation. Now we are ready to solve. And when we do solve, we get 1 times 1 is 1. 1 times 750 is 750. Right? 0.5 times 1,000 is 500. And when we multiply 750 divided by 500, we get 1.5 tab. All right. Now that had a little extra step, but that's okay because you're ready for it, and I believe in you guys. You can do this. This is the heart of dimensional analysis, is being able to use those conversions in your equation, okay? So you may not always have the problems where the unit of measurement are the same. Just like when you did D over H times Q, the units of measurements were not always the same. Sometimes you had to do some conversion. So it's the same with dimensional analysis. You just put that conversion right into your equation, okay? Let's go on to our next problem. All right. We have synthroid 0.1 milligram ordered, and we have available synthroid 50 mics. How many tabs will you give? How many tabs will you give? Let's go right into our dimensional analysis setup. We are looking for tabs. So we're going to put what tab we have. One tab is 50 mics. All right. Mics, right, has to be in our numerator. Do we have mics in our order? No, so we're going to have to put the conversion in here. Now, you remember our problem before I wrote out your conversions. You remember that 1 milligram equals 1,000 mics. All right, so let's just put that conversion right into our problem, and we need mics to be on top, so we're going to put mics on top because we want mics to cancel out. 1 milligram. Are we through with this problem? Can we solve? We cannot solve because although we canceled out mics, we've introduced milligrams. We're trying to get tabs by itself. So now we got to get rid of milligram. But we use our problem. We have 0.1 milligram here. And we can do that as 1. And if we multiply all the way, which I wrote so big till, I'll just go ahead and move up a little bit. 1 times 1,000 is 1,000. 1,000 times 1.5 is what? Get my calculator out back. 1,000 times. Did I say 1.5? That's right. You have to check yourself. 1,000 times 0.1. Let's see. Times 0.1. My calculator was going out. All right, 100. I'll put it over here. 100. Then 50 times 1 is 50. And of course, times 1 is 50. So 100 over 50. 100 divided by 50 is 2. 2 tabs. Right? Correct. I don't know where I think I said, I thought I heard myself say 1.5. If I did, I don't know where I got that from. But it's always good to write out your problem so that you can check your work. Always go back, check your work, make sure that you are putting in what you have written down, what your equation says, okay? That was a good example of saying something that's not even in your equation. So check yourself and make sure that you are putting in your calculator what's in your equation, and that you're writing what's in your equation from your problem. So let's keep going here. We have gabapentin 250 milligram PO daily. We have available gabapentin 0.1 gram per tab. How many tabs? So let's go right into setting it up. We got our tab. That's what we're looking for. One tab is how much? 0.1 gram. We already know we are going to have gram in our numerator. We do not have gram right here in our order, so we're going to have to convert. How much is a gram? It's equal to 1,000 milligram. So we want to keep gram in our numerator up here to 1,000 milligram. We can't solve yet because we need to get milligram out of our equation here. So we're going to go back to our order that we have. We're going to put our 250 milligram in. That is going to cancel out milligrams here. Now we are able to solve. 1 times 1 is 1. 1 times 250 is 250. 0.1 times 1,000 times 1, right, is 100. And when we divide 250 divided by 100, we get 2.5 tab. Or tabs. All right. Great. You guys, I know you guys are doing great. I know you guys are understanding this and doing awesome. Let's look at our next problem. Ibuprofen, 1.5 gram. What do we have available? Ibuprofen, 500 milligram. How many tabs? How many tabs? Let's find out. Tab equals 1 tab equals what? 500 milligram. We need milligram in our equation. Y'all already remember 1 gram equals 1,000 milligram. We need milligram in our numerator here. So we got to put milligram in our numerator to 1 gram. Now we need to get gram out. But we can look to our order for that. 1.5 gram. And there we have it. It's canceled out. We can solve. Right? 1 times 1,000 is 1,000. 1,000 times 1.5 is 1,500. 500 times 1 is 500. 500 times 1 is 500. So 1,500 divided by 500 is 3 tabs. And there you have it. That is dimensional analysis. And I believe that was our last problem. It is. That was our last problem. So again, go back, rework the problems, get you some more practice in. It doesn't hurt to practice. The more you practice, the more comfortable you will get with doing these problems. Now, I want you all to have a great day, a great study, a great practice, and I look forward to our next lecture. Bye-bye. Here are some common dosage calculation conversions. 1 gram equals 1,000 milligram. 1 milligram equals 1,000 mics. I promise you, you will use those a lot. 1 kilogram equals 2.2 pounds. Another one, use it all the time. 1 milliliter equals 1 cc. 5 milliliters equals 1 teaspoon. 15 milliliters equals 1 tablespoon. 1 liter equals 1,000 milliliters, and 1 ounce equals 30 milliliters. You will use those ounces to milliliters a lot with your intake and output. You definitely will use grams and milligrams and mics conversions with your dosage calculations, and you will use kilograms and pounds with your weight conversion. Especially if you take care of a lot of CHF patients, you have to weigh them daily, and you may need to convert their weight if you weigh them on a device that gives you their weight in kilograms, and you want to know what pounds, or vice versa. So all of these conversions are very common to use. I would advise you to commit these to memory, you guys. Commit to memory. Thank you for watching. Look forward to our next lesson. And this lesson, of course, is presented by Apex Nursing Academy. Have a good day, you guys.